my dear thinkers, on this 12th May 2026, I'm so happy to share you a project which is Arduino based. Okay? So this is a soil moisture sensor, and then this is a Arduino microcontroller board, and we have a relay module too. The purpose of this project today is during the summer vacation, we all are going to various outing, like vacation outing. So we have a lot of plants at home. And who will take care of watering for those plants? By the time we return back, our plants are, some of them are very weak. And throughout the year, we grow them with so much love. And we really like our plants. But, so this is a big problem. Not only for that, even for various other plants needs watering. Plant needs watering. So, whenever the tree or plants needs water, this sensor will identify that. And it will check, the signal is checked by the written program here in this microcontroller, and it will activate the relay module, and the relay module will pump the water to the plants or the trees for all the agricultural purposes, what I mean to say. You understand? So before that, I want to make sure you all will understand the agricultural motor pump. So I have one pump here, suppose say. So I have a battery, 12 volts battery. To run that my agricultural pump, I have a 12 volts battery. It will run the agricultural pump. This adapter is going to power my microcontroller board. I can connect this one here. And then see how I have tinkered this circuit, this board. See, there is a power input, and when the relay module is on, and then the output comes. Whatever power you give at input port, the same power will come at output. So that it will run our agricultural pumps or motors and whatever, right? So, to make this my board work, I can use this adapter or 12 volts connection what I am giving here, the same 12 volts I can take another connection and feed to this. Or otherwise, to make you understand more easily, I can use a 9 volt battery and I can use a switch here, and whatever program written in this, that can execute through the 9 volt battery if I use the battery like this. That's how I have tinkered this board. Okay. Now my dear friends, so what I am trying to do is I can connect this one. I have the adapter, the 12 volts DC. From the adapter, I am powering this. You see? Now I am going to switch on that adapter. So all these things are coming up. So Arduino board is powered now. Already program I have written and loaded the program there inside the Arduino board. And now you see this module is also ready, and relay module is also powered from this Arduino board. For this board and this module, for these two modules, the power is provided by this Arduino board. Okay. Now this is a sensor, my dear children, my dear thinkers. This is a sensor, soil moisture sensor. So if you push this into the roots, the plant area, so whenever the soil around the plant becomes dry, and this fellow will understand, the program will compare the output of this module, and whenever it is so less, it is so dry, and at the time this will give an output to the relay module, and the relay module will give power to the motor. And we have the motor here. This is agricultural, here is a motor. So this will take the water and it will provide the watering for the required plants and or the trees and whatnot, right? So this is what we are going to experience. So my dear children, this is what is a setup for now, but we want to test it. Before testing is, I am going to educate you in a different direction. So we'll use all this later, but on a paper, let me explain how the motor works. Suppose say here is a motor. This is called pump motor. So here is a pump motor. So this pump motor, you see what it is there for this pump motor. There is a power wire. My dear children, there is a power wire here. Okay. And then if I connect this power wire to the required power source like a battery, and the motor pump, this water pump works. And it will take the water intake. This is the intake. And that means if you drop it to some water tank or kind of tub or whatever, and it will take the water inside and it will pump the water at this outlet. So we can connect this to our plants or whatever. Okay, this we can connect. So this is what is the setup now. We can test it. Today we are going to test it also. But before that, I want to make sure this particular electricity, this electrical connection, how do we connect to my control board. Here at output, I must control this. So what I will do is, I will use another connector. I will be having some connectors. I use this connector I will use for connecting my battery to my input port of my power input, okay, for the relay module, because I want to connect. And after this, see, now I am connecting this cable to my battery source, okay. So negative to negative, positive to the positive. I am connecting, okay. So now the 12 volts is coming here. Let me see the meter. With the meter we can check up whether the 12 volt has come here or not. We can always check up. This is how we need to learn the things. Understand? You see the negative and the 12 volts of the battery is there here. Now this we are going to push into this relay module. This is going there. Now if it comes out, that's it, our motor will work now. Okay, so I made in such a way, the motor will be on, because in such a connection I made here the common pole and the NO and NC connections I have connected in such a way, this power will automatically come here, and when the water is full there, and it will be offing because of this sensor. That's what I want to test now. So let me connect another pin connection. Here such kind of one pin is there, you see, this kind of pin. There? No, not this pin. This pin. You see? You'll find, this one. You see? This one. Yeah, I have here. See, I'm going to open this because I want to. You see? Now I have two connections here. Right. Negative, positive. So if I connect this one here, and whatever input power I have given, the same power must come out here. So let me check that whether it is coming or not, the negative and the positive. Okay, it's not coming because relay is off. Okay, good. Suppose for example. Now this one I am going to connect to my motor. Where is my motor clips? Here, my motor clips. Okay, positive is connected. The negative is also going to be connected now. Yes, these two are connected. Now whenever my relay is on, automatically, they will be. Now I am going to power on my Arduino board. It is on. Because the Arduino output has not come to this particular, the output of Arduino board is not connecting the relay. That's why the output, the motor is not running. Now I want to make sure by just putting this one in some water. So we are going to put this one in some water. So I am trying to put the sensor. See, the output has come and relay is on. Now the motor is running. This is how we need to figure out. You see, if I remove the sensor from the water, the sensor output is gone, no output. So no relay input. Relay is off. Again relay is on. You understand?
Sir.
This is how we need to understand. So whenever water is there, the relay output is on. The relay's output is on. That's why it is making the relay on so that there is a water. So the connection, the motor is off. When I am removing, there is no water there to the sensor, then the motor is on because there is no water there to the tree. This is how we need to understand. Okay, good. Now we are going to check that in real world. Okay, my dear students, now it is a time for you to understand all about today's tinkering. Today's tinkering is all about a soil moisture sensor to water the plants automatically. Whenever plant needs water, whenever the sensor finds the dryness at a plant place, the root place, in the soil place, then immediately output will come. And when output comes, relay module connects the power, input power to the output, and where the motor works. You have seen there. You like this. You see there how it is. So it will plant, it will water the plants nicely. And whenever the water, the wetness is more than the set value, then automatically it will be off. And again few days later, based on the weather conditions and the summer conditions, when the plants roots will become dry, automatically because the sensor will find, understand, and the signal will go low, and the controller will compare that with the program and then sends an output to this, like the way it is sensing now, and the way the motor is pumping the water. You understand? So this is what is today's tinkering. Now I am going to explain on a paper how it works. Is it clear to all of you?
Yes.
So we found a small problem here in the connection problem. So we solved it. So every day we are finding some problem, right?
Yes, sir.
So problem is not a problem. Having no problem is a big problem because we miss opportunity to solve the problem. So we are lucky fellows to get more problems.
Yes, sir.
So we are understanding more and more and more. Okay then, now we will go for the theory part of today's project. What is today's sensor? Who is going to tell me what is today's sensor? Moisture sensor. Okay, come on boys. Ready? Hello my dear tinkers. So, here is our what is this? Okay, now we need to make sure it is well watered. So how we are going to do that? Say, so we need a sense whether our plant or tree needs water or not. Come on, come on. So we need a sensor. That's why we have a sensor here. Soil moisture sensor. So we'll keep this soil moisture sensor. Okay. Then what happens? Whenever the plant needs water, I mean the soil is dry. When soil is dry, the resistance between these two probes are so high. This is the point you need to understand. The sensor is working based on the resistance between these two electrodes. Here there are two probes. So that is why the angle, the sharp it is, we can insert into the soil. So this connectivity, this conducting material is in touch with the soil on the both sides. then what happens when the soil is so dry and the resistance between these two electrodes, you can say, or terminals is so high, and when the wherever we insert, if the soil is somewhat wet or more the wet, lesser the resistance between these two. These are the two pins. Okay, my dear friends, you can understand there are two pins. You can use your digital multimeter to measure the resistance between these two. You can always use resistance, use a digital multimeter, put it in a resistance mode. You see, the maximum resistance mode 2 mega ohms. Can check that. It will show you open circuit because there is no connectivity, there is no conductivity between these two. That's why it is an open circuit here. But whenever there is little conduction, then definitely resistance between these two pins will come down. More the water, more the conduction, lesser the resistance. So based on this resistance, we have used another interfacing module here. So this will read, there is a special program written here. So based on the resistance between these two pins, the output is activated. So here is a sensitivity preset. So you can set the output of this module to be high based at what level of conduction. So you understood the working principle of this particular sensor, soil moisture sensor. So whenever you buy this, then immediately you have to buy this one also, because the output is more important. You will get here one digital output and one analog output. I will educate you how to use the analog output later. Exactly at what moisture, at what analog signal. Digital means at what set level you need to see the presence or absence. Water is present, output is high. Water is absent, output is low. Like that, directly on or off. That is a digital. That analog is for linear. That next level of mentoring, I will explain you how to use the analog for what all the various purposes. You understand? So presently, what you need to know, at what water level, the water, because every plant requires a different water. Some plants require more water, some trees require more water. So even little water is sufficient for some trees. So based on the water requirement of proper watering to that particular plant, we will set the output high or low, at what level. But here in the program, what we will write in the program, whenever the sensor output is high, then you keep the relay module off, so that the motor will be off, which is planting the water. You understand? So that much only we will write in this program. Okay, very simple. When the input is coming high, that's it. You stop the signal to the relay module, and relay module is off, motor is off. So no water coming out. But whenever the plant running out of water, whenever the conductivity, the resistance is less between these two, and we have set the value in such a way, the sensor output is high, and that's where this fellow will give a signal to the relay module, and relay module is on, and the power went into the motor, and it pumped water for the tree to be watered. That simple is this. But how we have written the program, how we have uploaded the program in this Arduino board is tomorrow's class. So what are all the various sensors? Few more sensors tomorrow. And how we are going to connect them, for what purposes we are going to connect them, how we are going to write required program for that purpose, and how we are dumping that program into the Arduino board, and then how we are powering the Arduino board and checking the input and output. All that we will discuss in tomorrow's session. You understood? Is it clear now?
Yes, sir.
So can we draw a block diagram of this module here?
Yes, sir.
So the block diagram of this is so simple. So what I have here, I have a sensor. For you, same drawing. Okay, this is a sensor. So we have two connections here. The output of the sensor is going home, the interfacing module. This one. So the sensor is connected to this module. The module output is going home, the Arduino board. Arduino board output is going home to the relay module. And relay module is controlling home the motor. Pump motor. So this is pump motor. And this is relay module. Why we call it as relay module? Relay is different, relay module is different. I will explain it tomorrow. This is our microcontroller programming Arduino board, and this is a interfacing board. This is a sensor. And we need power, DC power to this also. That's why we are connecting that 9 volt or 12 volts adapter or battery, whatever. And we also need power for this motor. 12 volts DC. Here we require more current, around 2 ampere current we require, because we need to run the motor. So it will pump, it will take the water from the water source, and it will water the trees or plants. So why we have programming here? This is very important. Why do we need programming here? Without Arduino board, without programming, what happens? It can be directly connected to the relay module, and it can output of this can be directly run the relay module without this Arduino board and all. But why we need that? Tomorrow we will discuss in a special. Is it clear now?
Yes, sir.
This electronic circuit, this interfacing, this module is special because this electronics we cannot keep it on here because this has to go in the soil. That's why they have separated. But they have not used this circuitry on this microcontroller board because this one is common for many. That's why we have used a special circuit board for this. This is interfacing this sensor to the analog digital outputs. It also requires some DC 5 volts. So this also requires DC 5 volts connection. And relay module also require DC 5 volts. All these 5 volts DC is provided by this Arduino board. That is a special connection. We have that. So it will take some 12 or 9 volts for DC, and it will convert that 5 volts for such kind of modules. That is anyway it is available for all the sensors and all. Okay, so you don't need any power supply for these fellows, but you need a power supply, high current power supply, because the motors, actuators, they are called actuators, okay, motors and all. They need high power because they have to pump the water heavily. That's why I have connected the battery, because this battery can supply 12 volts at 7 amperes. So 2 ampere is just nothing. You understood, my dear friends?
Yes, sir.
So is it okay with you today?
Yes, sir.
Any other doubts you have here? So you understood soil moisture sensor and the interfacing module. So these two are paired. They are the pair. Okay, you will always buy them in a single packet. It's a pair actually. But you can always replace with any other this probe. This is called probe, sensing probe. They are generic fellows. There is no uniqueness in that. They are the generic fellows. You can use any probe for this, or you can use any this particular interface from any other interface for this particular purpose. So they don't. I mean, when I say that it's the paid, that means this and this only have to be together. No, it's not like that. You can always use any other probe to this, or any other interface to any other probe. It works. So this is a single channel relay module. It's sufficient enough to control one pump. So why do we need to use the relay module? What is the importance of it? This and all tomorrow. Basically, this particular Arduino, it has got the brain, the mind. It can control the way you require according to the programming instructions. But it cannot handle high powers. High power in the sense high amperes. 12 volts into 2 ampere is 24 watts of electricity it cannot handle. That's why we are using a relay module. So relay module is getting controlled by Arduino's outputs with very milliwatts of energy, but it is controlling watts of energy, 24 watts or 50 watts or 100 watts, up to whatever power you want, we will get the relays in that bigger size. Is it clear? So relay module is to, what is the function of this one? With a minimum signal power to control the maximum powers for the motors and many other solenoids or whatever. So I think this is a block diagram. You understood? So on this 12th of May 2026, I have explained this block diagram in a practical way. So in the beginning, I have shown you the practical setup, how it works. So you are more excited to know theoretically. Now, instead of going all the practical connections and circuit drawing and all, I made you understand on a block diagram. Now tomorrow if you ask me, I can connect and show you all the wiring connections and all, and we can see the program how we have loaded. We can always do that. But is it clear to you? Tomorrow we will work with more Arduino projects, okay? That's how we will go next step. Okay then, my dear Tinker Masters, signing off your Tinker Master Srinivas from scientificstudents.com. Bye bye.